So hello everyone, and today we will have a short talk about network discovery, network topology discovery, how it works. So a little bit about me. I started my IT career in 1994, and I was using open source basically from the beginning. I started development of the open source monitoring solution, which is called NetXMS, in 2003 as my hobby project, and I was working as a network engineer at that time. And I co-founded a company that is offering support and custom development for NetXMS in 2009, and since 2013 it's my full-time job to lead the development of NetXMS and also participate in the management of said company. So why do we need network discovery in the first place? So we usually want to create nice maps of our networks, preferably automatically, so we don't need to draw it, and we want them up to date. We want to correlate events in our network based on topology. So the very simple example, when we have an upstream router down, you don't want to get a lot of alerts for all devices behind that router. We want to correlate them into a single alert. We want to detect changes in topology because somebody may just plug in something in your network, and otherwise you will never know. And to find something long forgotten in your network, and those are real life stories when people run network discovery in the big industrial network, and they found some devices long forgotten, but they're still there, they're operating, and they're important. So strange things happen when network is old and evolving. So there is two parts of network discovery. To discover new devices connected to your network, and to discover the topologies, how everything is actually interconnected. The first part, we have two approaches. We call it passive, when we go from the single seed node, and then we find the neighbors of that node, and we take each neighbor as a new seed, and then we go further and further through the network. And active, when we basically just scan address ranges. For passive discovery, the main source of information is IP neighbors. And it will be ARP caches on devices for IP version 4 and neighbor discovery protocol caches for IP version 6. And basically, we just read all the IP addresses mentioned in the ARP table and took it as potential target for monitoring. The routing tables, another useful example, another useful source of information. We can take host routes, we can take gateway addresses from routing tables, and this is really helpful dealing with point-to-point links or any other links when we don't have ARP protocol. And this actually allows our passive discovery to hop through the serial links, for example, in the network. In NetXMS, we also use other sources of information about IP addresses. So any syslog message that for some reason comes to the management server, any SNMP trap received, we can take the source address and use it as a potential device to monitor. And we also can support proprietary methods, proprietary MIPS, like an example, MikroTik neighbor tables. So anything that is specific to certain equipment. In NetXMS, we have a special layer, we call it network device drivers. Those are pluggable modules that hide vendor specifics and provide unified information in a unified form to the upper layer. ActiveScan, that's really simple. We just send out packets and listen for responses. Whoever responds is our potential target for monitoring. So we can use ICMP ping, which is obvious. We can send out SNMP GET requests, and some devices may respond actually. And we can also send out TCP SYN packets on a set of well-known ports, and if any device responds, we know that this IP address is alive. We can try to monitor it. And now the second part, to discover the topology. So we want to end up with something like this, with a nice automatically built map of our devices, how they are connected together, on what interfaces they are connected. So what we do for that. There are certain prerequisites to be able to do topology discovery. So ideally you have to discovery protocols to be enabled on your devices. LLDP, which is preferred, or CDP, and of course all devices, network devices like switches and routers, they should be accessible by SNMP from network management system. The monitoring system will take some preparation steps. So for each device that is added to the monitoring, we will read full interface information from that device: name of the interface, description, MAC address, IP addresses, because we will need this information to match topology data. If device supports breach MIP, which is normal for all switches, then we will read breach port mapping as well from breach MIP. And if device is LLDP capable, then we will read LLDP local port information as well. Then we have multiple sources of topology information, and the first and most important and most reliable usually is LLDP. It's an industry standard now, and like a brief summary how LLDP operates. So each LLDP capable device will send at fixed intervals information frames that can be received by other LLDP capable device. And if we talk about switches, the switch will work in a bit unusual way. It will not forward the frame as it will do with any other frame. It will receive it and process it, and on other ports it will send its own LLDP information frames. So each frame contains a sequence of TLV structures, and there are a few mandatory TLVs, which basically what we're interested in. It's a chassis ID, port ID, and time to life. And this is chassis ID and port ID, which is important for topology discovery. So what we do, for each device, we will read LLDP remote table, which contains entries for all LLDP information frames received. So for each peer detected by this particular device. And we will use attributes of each entry to find other device known to the monitoring. So we will use remote system name, remote chassis ID to find the device in the monitoring, and when we found it, we will use remote port ID to find actual interface on that remote device. And if we found a match, we can add a link to our internal topology representation. Another source of information is CDP, which stands for Cisco Discovery Protocol. And it's still in use, although it generally is superseded by LLDP. It has same operational principles as LLDP, so basically we will do the same stuff, but we will use different MIPS. Another interesting source is switch forwarding database, or sometimes it's called MAC address table. It's not a protocol as such, it's just a table within the switch that determines to which port the switch should forward frames destined for specific MAC address. And if we read MAC address table from the switch, we can identify ports that only have one MAC address known on them. And we can assume that this is only one device connected to that port, switch port. So we can add a topology link connecting that device, which may not be manageable at all. So it may be just, we can just ping it and know its MAC address, and we know it, okay, it's connected on that switch port. And this is a MAC address table example, and we see that the first 3 ports has only one MAC address, so we can assume these are end nodes connected. It's not some link between switches. Another a bit unusual source of topology information is spanning tree. Spanning tree protocol was never intended to be protocol for topology discovery, but still we can get some information about connectivity between switches from spanning tree. And we can use it as last resort if we don't have LLDP or CDP between switches. So how spanning tree operates, when the switches are connected in the spanning tree domain, they elect a root bridge, and then every switch will have a root port. This is the port that points to the shortest path to the root, and it will also elect designated ports that are pointing to other switches that also support spanning tree. So we will go through all ports and read designated bridge and designated port values. And that means that if we read this switch, we will find a designated port looking here, and number 4 will be designated bridge, and this interface will be designated port on remote side. And so we basically know the MAC address of the switch, MAC address of the port on the remote switch, and if we can find it in the monitoring system, we can create a link in our topology. And yeah, in NetXMS we can also deal with proprietary protocols on specific requests. We did that a few times. Again, we can create a driver that will read vendor-specific MIPS and extract some topology information from there, and then we combine it in the single big picture. We've had a lot of challenges here. LLDP is really nice in theory. The problem is there's a lot of vendors, especially maybe not from the top. They implement LLDP in a wrong way, so they may send wrong information LLDP packets itself. They may send everything correctly on LLDP level, but they may report absolute garbage on through the SNMP when you read this LLDP MIP. So we actually have a lot of code inside the monitoring to deal with inconsistencies and incorrect data in the MIP in devices from different vendors. So those are some comments from our code related to specific devices. So that's it, the quick overview how we do the network discovery. If you have any questions, you can ask us later, visit our website. Thank you.